Everything we consume must be broken down or metabolized by our bodies so that we can extract nutrients and energy from them. Here's Jamal eating some of his favorite foods high in carbohydrates. Glucose is an example of carbohydrate, but how is it broken down in our bodies for energy? Glucose is an essential molecule in metabolism and for energy. Glucose can be converted into pyruvate through a process called glycolysis. This process occurs outside of the mitochondria. The next major process is called the Krebs cycle, and it takes acetyl-CoA and other molecules to produce NADH and FADH2. These are called electron carriers. These electron carriers are then used by the electron transport chain to produce ATP, a molecule that we get our energy from. So what connects glycolysis to the citric acid cycle? That would be the pyruvate dehydrogenase complex, or PDC. It is responsible for converting pyruvate from glycolysis to acetyl-CoA so that it can enter the citric acid cycle. This is what the pyruvate dehydrogenase complex looks inside of our body. The PDC is made up of 3 enzymes which are commonly referred to as E1, E2, and E3. E1 receives a pyruvate molecule and then undergoes a decarboxylation reaction, which generates a CO2 molecule, and then binds to a molecule called TPP. This new intermediate product then interacts with the lipoamide, and the whole thing moves to E2. In E2, the acetyl group from molecule gets removed and added to cofactor A, and look, we've made acetyl-CoA. We are left with a reduced lipoamide, but don't worry, he'll be fixed by E3. E3 uses FAD and NAD+ to reoxidize the lipoamide so that it is restored to its previous form and can be used by the PDC again. When the PDC fails, there are a number of medical issues that can ensue. Pyruvate can get converted to a molecule called lactate, and that is no good because it can cause acidosis. PDC deficiency can lead to neurodegenerative diseases, muscle weakness, diabetes, cancers, and in extreme cases, death.
Created using Powtoon.